Welcome to our virtual conference today. Today we are going to talk about authoring grammatically correct conversational templates for Siri. Hello, I'm George Roten.
And hello, my name is Martin Reddy.
We both work on Siri at Apple. And the agenda today is pretty simple. What is the problem and how do we fix it? So to start off with, what is the problem? What is this topic about? We need to generate a message on a computer. The message needs to be grammatically correct. The message needs to be translated into other languages, and it needs to be pronounced correctly. And as we go through this topic, I'm going to make assumptions like you remember some of the basic parts of speech from English class, like what is a noun, adjective, verb, adverb, or pronoun, and that you can count things. The message is going to have a pretty clear definition of what the verb is being used. We're not changing to any arbitrary verb. It's pretty constant as to what verb is being used. We're not providing user vocabulary of verbs. It's pretty constant. Now in the messages, you could say you had one missed phone call yesterday, or you have two new messages, or you will have 3 meetings tomorrow. Those would be 3 separate messages, and they each have the tense pretty clear. The word is, or had, or have, or will is constant. The message to display can contain user vocabulary, and it could also contain a finite set of context-sensitive words. And I will go into more detail about that later. But to start off, let's talk about some examples, some concrete examples. So let's start off with agreement, like in grammatical agreement. What could I put in front of that word? I could put the definite article, like the agreement. There's only one definite article, so no variability there. It's pretty clear. But once I get into the usage of an indefinite article, I could either use an or a. Well, which one do I use? Well, I put the an in front of words that start with a vowel and a in front of words that start with a consonant. Obviously, I wouldn't say a agreement. I would say an agreement. So you might think, oh, okay, so I just have to check if the word starts with a, e, I, o, or u, and therefore I use an. Otherwise, I use a. Well, that's usually correct, but there are edge cases. So I could say an umbrella. I could say a unicorn because y is a consonant, or at least it's considered a consonant. And I could also have an LED light. LED is not lead, it's spelt out. So it really does start with an indefinite article. What else could I put in front of the word agreement? Well, I could put a number. So I'm counting a quantity of agreements. As you might guess from that, I might have a scenario where I have 1 agreement or 2 agreements. But in this case, if I hard-coded the word, I just plop it in there, I now need to make sure that when I use 2, I change the noun into the plural form. So I have 2 agreements. You might think that you could just add s to any noun where the quantity is not 1. Well, you wouldn't be correct. There would be times where you have 1 yen or 2 yen, but you wouldn't have 2 yens. You don't add s when you count the Japanese currency. So you might think, okay, well, maybe there's a few cases where it might add an s. Well, there's also cases where the word goes through a morphological transformation, where there isn't a clear mapping between the words, like goose and geese. So I'd say 1 goose or 2 geese. The plural form of goose is geese. You have several other words like that, like woman, women, man, men, child, children, person, people. You have all sorts of those scenarios. So you need a bit of a dictionary in there or something to know how you change the word from singular to plural form. Again, this is dealing with user vocabulary, and you may not necessarily know ahead of time during build time of your message if the word coming in is going to be singular or plural and how the word maps from singular to plural. Let's move on to a language like French. Let's try these 4 words and just realize that my French is not very good, so I'm not going to try to pronounce these. Just recognize on the screen that they represent different words and they each have different interesting issues with them. So we have accord, accords, phrase, and document. If I put it on the definite article like in English, I now have to use 4 different forms of the definite article in this case. And if I use the indefinite article, well, I don't have 4, but I have 3. If I want to quantify the words and put a number in front of them, I might just get away with, just putting the number of digits in front of the word and, changing the grammatical number of the noun from singular to plural as needed. But what if I need to pronounce the number? In this case, you might notice that the indefinite article and the number 1 are pronounced the exact same way. And that's an interesting point because in a lot of languages, the indefinite article and the number 1 are pretty similar. They're typically the same pronunciation. But when you write it as a digit, you don't get that distinction and it becomes hard to pronounce that number. So I gave some examples of handling 2 words and getting those 2 into grammatical agreement. What about whole sentences? Let's start with a simple sentence. So in this case, we have the light is on. Pretty simple, no problem. So in this message, let's assume that we're inserting the word light into the message, and it could be any arbitrary user vocabulary. And that's the key part, user vocabulary. You may not know until runtime how this message is going to be formatted. This normally seems okay until you make sure that the word is plural. In that case, once you encounter a plural form, well, that doesn't quite sound right because you're supposed to change is. You don't say the lights is on, you're supposed to say the lights are on. What if we change it from light or lights to the light on the front porch is on? Okay, so we're not just checking if the final word is singular, plural. Now it's the word right before the preposition. So in this case, we want to say the light on the front porch is on and the lights on the front porch are on. We've given some examples in English and how there's some grammatical agreement issues for English. Let's try French. In this case, this is also the light is on. And you might think, oh, okay, the word here, the word light, might just change the word is, just like English. So you might think, okay, I'm just modifying the grammatical number. We're changing it from singular to plural, no problem, until you realize it's a lot more complicated. So you have to change pretty much the entire sentence. And we have to use the definite article on the word for the light, and we have to change the word is, and even the word on changes. So the word on depends on the grammatical number and the grammatical gender. Likewise, the word is the grammatical number and grammatical gender, and the definite article depends on the grammatical number, gender, and whether or not the noun depends, and the definite article also depends on whether or not the word starts with a vowel. Here are some examples of how that message might come out if we're just changing the word light to some other noun. In the first example, it's the light is on. In the second one, it's the lights are on. Third one, it's the device is on. The fourth one is the fan is on. And the last one is the fans are on. And I'm really not going to try to pronounce these words because my pronunciation is French is atrocious, but just recognize that the spelling and grammatical agreement varies the sentence quite widely. So I said a lot of things there. What are some common things to consider when getting words into grammatical agreement in a message? Well, earlier I mentioned gender. So you have masculine, feminine, and in a language like German, we have the neuter form. We also have, in some Scandinavian languages, it's not just masculine, feminine, and neuter. You have the common gender, which is where the masculine and feminine forms become the common or gendered form, or the neutrum form in, I think, Swedish. We also have gender that can be associated in the following ways. It can refer to the object, like in German, Spanish, French, and Italian. Gender can refer to the speaker, like in Japanese, Thai, and French. It can also refer to the gender of the audience, like in Arabic and Hebrew. This value can interact with concepts of Russian animacy and whether the object is human. And the gender of the object is usually artificial, and it requires existing knowledge of the language. So you might have to have some data in the background to recognize the gender of your objects. We also have a grammatical number. Typically, it's whether it's singular or plural. Some languages don't have singular and plural, they just have one form of the noun. But then you get into a Semitic language like Arabic or Hebrew, and in that case, you have the dual form also. And when you have a quantity, you may not have a number next to the noun. You'll just use the dual form just by itself without saying the number 2. And the grammatical number can interact with the declension or grammatical case, like in some Slavic languages and Finnish. And I just mentioned case. What is case? Case varies widely between languages, though typically you have the nominative case, which is usually in the dictionary form or what you would find when looking up in the dictionary. It's frequently considered the lemma form, and it's usually used in isolation when you're talking about the nominative form. Some languages add suffixes to get into the additional cases instead of individual words. Some languages morphologically change the spelling of the word, so instead of just changing the suffix, you change letters in the middle, like in the case of goose versus geese in English. Sometimes more than one word can be affected when changing the case. Prepositions like in, with, to, from, and of are examples of words that could morphologically combine with a word into another surface form. So in order to create another case of the noun being referenced. We also have the concept of definiteness. Many Romance languages have prepositions that note form as definite or indefinite. In some Scandinavian languages, they will change the surface form of the noun to note that the form is definite or indefinite by adding an additional suffix. Hebrew also has a construct definiteness state that is used when the phrase is a mixture of 2 or more nouns that are definite or indefinite. And Arabic has a definite prefix. We also have adpositions. There are a number of other adpositions that could be modified depending on the grammemes of a given word. A grammeme is a grammatical category value like the examples that I provided earlier, like gender, grammatical number, case, definiteness. These adpositions could include that, of, the, an, with, in, around, about, to, from, on. Those are adpositions that are frequently affected. An adposition can be a preposition or a postposition. If it's considered a stop word in English, it could be combined with a neighboring word to create a new word in another language. When an adposition is added to a noun, it's typically considered a new grammatical case. Turkish and Finnish are agglutinative languages that have classic examples of this happening. Typically, Turkish and Finnish will just add suffixes to the noun to note additional cases. We also have the concept of pronouns. A pronoun is a generic way to refer to a noun while assuming that the listener knows what it's being referred to. Some examples of pronouns include I, me, we, us, you, he, him, she, her, it, they, them, and probably a few others. And just so that you get a little bit more clarity about what a pronoun is, let me give you the example of I love it. What would the pronouns be in that phrase? They would be I and it. I refers to myself, and it, presumably the listener knows what it is being referred to. We also have some other things to consider, like pronunciation properties, like in the case of the indefinite article in English or in the definite article in French. You also have to deal with list of items. So you have a list of items. You could have a conjunction list or a disjunction list. A conjunction list is involving the word and a disjunction list is involving the word or. You can also have adjective lists, which you might see in some Chinese and some East Asian languages. A quantity can take on a combination of grammemes from either the number or noun, and they combine together to create new interesting combinations. In Russian, this can be rather complicated, and I will highlight that issue later on. So I did mention formatting a list. Let me give you a more concrete example there. In English, I just have 3 items in the list. It's Jane, John, and Ivan. Now in Spanish, I could also have a conjunction list, but I will actually vary the word and depending on the following word. But in Korean, it depends on the vowel properties of the previous word. So you may notice that below, Jane doesn't have the letter E pronounced as a vowel, so it's a consonant, but Angela does have a vowel at the end. And you may notice that the suffix attached to those words changes depending on what is in the list. We also have to consider formatting a quantity. So we have 1 day and 2 days, but if you're familiar with CLDR plural rules, you also notice that, well, 1 day, 2 days, 5 days, 21 days, 22 days, 25 days, it's not consistent. It's not just whether or not it's not whether or not the number is number 1 or not. It's actually a little bit more of a complex formula. And then in Hebrew, you actually have 1 day, 2 days, 3 days, but it's almost, when you're reading Hebrew, it's from right to left, and it's like day 1, days in the dual form, or 3 days. When it comes to numbers, there are 3 things that you frequently have to consider. So let me give some examples. In the set above, we have the numbers 1, 5, 3, and 9. So those are just individual numbers. I have something called a cardinal. So that's when I say there are 4 numbers. So I'm counting something, whereas numbering is used in isolation. And then there's an ordinal, and that's where you're implying an order to the set. So like the second item is 5, and I could either use the number 2 and the suffix nd, or I spell out the word second. So in English, it's pretty simple, and if you follow that link down below, you can actually play with the rules that are used by CLDR's rule-based number format. In this example, it's pretty simple. There's not too many rules, and you may notice the verbose form in there. That's used for examples where you want to say 101 versus 101. The verbose form tends to add the and in it. This isn't common for many languages, but for English, it is a common thing to consider. For Spanish, you have a little bit more to consider. You have to start worrying about the grammatical gender of the noun being referenced. And then you have Russian to consider, where you have grammatical case that is also affecting the pronunciation of the numbers. So there's a lot more variation. And if you want to look at Finnish, I can't fit it onto a slide because there's just so many variations there. So just recognize that there are a lot of ways to pronounce numbers. And now that I've mentioned numbers, let's look on the other side of what would be considered as a part of a quantity, and that would be English nouns. In this case, we have grammatical case, nominative and genitive, and singular and plural. The genitive is frequently known as the possessive form in English. So we have whether or not the word is nominative and singular, it's bunny in this case, but if you get the plural form of that, it's bunnies with IES on the suffix. You actually remove the Y and add an IES. But if it's singular genitive, then it's adding an apostrophe S. And then if it's plural possessive, then it's bunnies with an apostrophe at the very end. If you start getting into a language like Russian, it's a little bit more complicated. There are 6 grammatical cases, and whether or not it's singular or plural. And those are the surface forms that you'd want to use. If you want to use it in a quantity, then you have a complicated table like this, where you're taking the previous set of words, combining it with numbers, and the entire phrase actually goes through a morphological transformation. And it's pretty complicated. It's not as simple as attaching 2 strings together. You need to have some logic. So with that, you're probably thinking, ow, my head hurts. Well, language is hard. We've had to come up with a lot of functionality for Siri because the industry doesn't really have a lot of good support for handling such scenarios where the user vocabulary may not be known until runtime. And so we've looked at other alternatives. So it is important to note the other alternatives that we know about. There's ICU. We've known that for a long time. A lot of this stuff was built a long time ago. More recently, things have popped up like Fluent and FBT, but they don't handle this level of user vocabulary. They don't handle knowing whether or not the word is singular or plural and getting other words into grammatical agreement. There's also GNU text, and uh, that's most that really does is it supports the CLDR plural format rules, but it's a smaller bit of functionality than what ICU provides. And there's also a Unicode message format working group that is working on trying to make messages more flexible in getting a message grammatically correct. And I will admit that I'm a part of that working group, so I may be a little bit biased as far as what should be done in that working group. For Siri, our solution was to come up with conversational authoring template. And let me hand it off to Martin to continue on how we created something called CAT in Siri to handle all these grammatical issues.
Thank you, George. So in the second part of this presentation, we're going to talk about how we try to solve these issues at Apple so that we can generate grammatically correct responses for Siri. We do this using a messaging format we call Conversational Authoring Template, or CAT for short. There are several parts to the CAT infrastructure at Apple. There's the file format itself, which we'll talk about in a moment. Then there's a runtime library, which is implemented for all Apple platforms. The primary function of this library is to read files in the CAT format and execute them, which means to expand out any runtime parameter values, perform any localized inflections, and generally create a fully resolved string to display or speak to the user. This library also provides a validation function to ensure that CAT files are syntactically and semantically correct. This is an important part of ensuring that we don't ship dialogue to our customers that will break or produce invalid results. We also have various tools that support the CAT format. This includes a robust translation process to allow our translators to take the original dialogue and translate that into all 40+ locales that Siri supports. We also have UI tools to help visually author and edit CAT files so that you don't need to be an expert in the file format syntax. And finally, we have command line tools that make it easy to work with and manipulate CAT files. For example, to execute and validate them from the command line and to help with deploying them to our customers. As for the actual CAT file format, there are a number of important features that I'll discuss today. We support an XML representation to make it easy to hand author files, and we also support a compact binary format for better disk space utilization and faster parse times. The command line tools I just mentioned include the ability to easily convert between these two representations. For Siri, we need to display the generated language on screen, but we also need to speak it using our text-to-speech or TTS engine. So for all dialogue that can be represented in a CAT file, you can specify separate printable and speakable strings where you need to. For the speakable strings, you can use SSML, or speech synthesis markup language, to control the prosody of the spoken language. CAT files also let you embed references to parameters whose values are supplied at runtime. So we can say things like the temperature right now is 80 degrees, where the 80 degrees part is computed at runtime by talking to an appropriate weather API, for example. These parameters are all strongly typed, so we know if we're expecting a string or a number or an array or even a complex compound object. And the validation functionality that we have for CAT files will perform type checking to make sure that all parameters are used in ways that are appropriate given their type. We also provide various ways to select between alternative dialogues. We do this with different grouping semantics. For example, we have a random group that will randomly pick between alternative dialogues. This lets us provide different phrasing so that it doesn't sound like we're saying the same thing all the time. We also have first and switched groupings, which essentially give us if-then-else controls. And we have an all grouping to let us output multiple lines of dialogue for a given response. Cat files can also define conditional logic, so we can output different dialogue based upon whether certain runtime parameters are provided or have certain values. We can essentially create complex Boolean expressions that test different aspects of these runtime variables, such as whether they're set, their value, their length, and so on. Finally, we have built-in support for a feature we call user grounding, which means to personalize output with the user's name. For example, we might say, "Okay, Martin, I've sent your message," but other times we might just say, "I've sent your message." Generally, when we first generate dialogue for a given feature, we might perform user grounding and refer to the user by name. But if the user interacts with the feature regularly, we'll drop the name to avoid being over repetitious. So here's a simple example of a cat file. You can see that it's an XML file, and we have a namespace that includes a format version number, 1.0 in this case. We also define the locale that the file represents. Different locales are represented in separate cat files. Then individual lines of dialogue are contained within a dialogue XML element. So this cat file has a single line of dialogue written in English that says, "Hello world." By default, any dialogue will apply to both the printable and speakable output. However, you can optionally break a line of dialogue out into separate print and speak strings. So this example here shows how you can specify the line of dialogue that's printed on the display device and the separate line of dialogue that will be spoken by the TTS engine. This example shows how we support runtime parameters. So we can define a set of parameters and their types in a separate parameters file. In this example, we have a parameter called user, which is a string type, and we also have a parameter called contacts, that's an array of person objects. At runtime, code that uses our execution library can provide values for these parameters. And in the cat file, you can use the var XML tag to insert the value of a parameter. You can see in the example here that we can access various built-in functions on these parameters, such as user.uppercase, which returns the uppercase form of the string value. Different types have different built-in functions, so array types have a built-in length property to return the number of elements in the array. And then you can do more complicated things like dereferencing specific array elements and referring to properties in a compound object, like the given name property of the person type. Once again, our validation support will check that all of these parameter references are appropriate for the type of the parameter. So if you try to do user.givenname, then that would produce a validation error in this case because user is a string type and doesn't have a property called givenname. Next, here's an example of the grouping selection behavior. This is showing an example of the random grouping element. In this case, we have 3 lines of dialogue under the random tag. So the runtime engine will randomly pick between the 3 lines and return just one of them. The engine remembers which line we return, so on a subsequent request, it will try to use a different line to avoid repeating lines in sequential requests. There are other grouping behaviors like the first element, but we'll need to talk about conditions first. So as I mentioned earlier, we support being able to conditionalize the output based upon the value of parameters supplied at runtime. We do this by creating named conditions that can describe arbitrary and or not combinations of expressions. In this case, I'm showing a single expression, which is testing the value of a voice gender string and seeing if it equals the value male. The string comparisons are case insensitive in cat. We can then use this name condition on individual lines of dialogue to indicate that that line should only be selected if that condition evaluates to true. This can be used in conjunction with the first element, which will iterate through each line of dialogue sequentially from the first one through to the last one, and it will select the first line where the condition evaluates to true. This is essentially equivalent to an if-then-else structure in a programming language. So in this example, we are dealing with the case that in certain locales, such as French, the dialogue you output depends upon the gender of the speaker. And Siri can have a male or a female voice, which you can select yourself in your device's preferences. So in this case, we're making sure that we output the correct inflection of "je suis désolé" based upon whether Siri's voice is male or not. And finally, here's an example of the user grounding personalization that I mentioned. All cat files have access to a built-in user variable that contains the current user's name, and there's a property on that object called grounding if needed that will ground, that is, display the user's name if the system decides it's appropriate. This is often used in conjunction with the opt tag, which will remove the enclosed text if any of the variables inside of that block produce no output. So what that means is if we don't ground the user's name, we will remove the text OK, comma, and the period after the name. So if the name is grounded, we might output something like, OK, Martin, it's done. And if the name is not grounded, then we'll just output it's done. So that describes some of the general capabilities of cat files. Now let's dive into the features that directly address many of the issues that George talked about in his part of the talk. There are several aspects of cat that are specifically focused around creating grammatically correct dialogue. This includes correctly inflecting nouns and numbers for all of our supported locales, supporting various units like time, currency, duration that are formatted differently in each locale. We also handle grammatical number operations, such as producing plural forms of nouns. We support formatting lists. There's a powerful feature that we call semantic concepts, and also locale-aware text transformations. And I'll go into all of these in more detail next. It's worth noting that the localized units are not covered by CLDR because it doesn't support pronunciation of numbers or modifying the grammatical case. So first of all, we support a wide variety of noun inflection operations that can be performed on the runtime parameters that we receive. We do this by adding the inflect attribute to the var XML element. Some examples of this are the plural inflect command. So for example, if the parameter noun has a value of chat in the French locale, this will return the string chat with an S on the end. Another example is with indef article that will add an appropriate indefinite article to the noun based upon attributes like the gender of that noun. So using the same French example, this would produce un chat. If the noun were feminine, then it would use une instead of un. There are also some morphological functions that are locale specific. So the with de prep is specific to French to decide whether to use de or d apostrophe based upon whether the noun starts with a vowel or not. Now you'll note that we could also do this with a condition, like we did for the je suis désolé case. However, when translators have to do this a lot, it makes it a lot easier if they don't have to write the same condition over and over again. Lastly, you can combine these inflection operations by providing a comma-separated list. So in the last example, we show producing the plural form of the word house in Italian with a definite article in front of it. For parameter values that provide a numeric value, we provide various ways to format those numbers. This is done with the number attribute to the var tag, which specifies various methods to format the numbers. So for example, we can format numbers as words, which is helpful for speaking them with a TTS engine. We can also format ordinal numbers such as first in English or troisième in French. And we can use locale appropriate digit separators like commas or periods. Turning these numbers into words leverages rule-based number formatting from ICU and CLDR. CAT also provides direct support for a wide range of localized units. Examples include how we represent quantities like time, dates, temperatures, currency, duration, percentages, and so on. In this example here, I'm showing how we support currency. You'll see that we have a specific currency type, and then we have special handling for how we display parameters of that type. We deal with producing both an appropriate display string, but also a speakable string for TTS. We also deal with talking about currencies that don't map to the locale of the user. So if we're talking about US dollars in the US, we'll just use the dollar sign. But if we're talking about US dollars in Canada, then we'll say US dollars. This currency formatting and pronunciation goes way beyond what CLDR can provide, including handling subunits, handling native and non-native currency units, and having all of the words in grammatical agreement. The non-native currency units and formatted currency comes from CLDR, but everything else is customized for Siri. And this is similar for all of our other localized units as well. Siri has built out a lot of customized formatting for all of these quantities across all 40+ supported locales. Next, we'll talk about grammatical count or grammatical number. That is using the right form of a noun based upon its quantity. For languages like English, we just have to worry about the singular and plural forms. But for other languages like Finnish or Russian, there are multiple forms to be concerned with. This is all done with the quantity element in cat files. The first example shows how you can provide the singular and plural forms of a noun given a count of that noun. So we would output dog if the num dogs parameter is 1. Otherwise, we'd output dogs as the plural form. The cat engine also has a built-in dictionary of how to pluralize many common nouns across all of our locales. And you can take advantage of that by providing the singular form and asking the cat engine to return the appropriate form based upon the number value. You can also have the number itself automatically included in the output, and you can apply the same number formatting that we just talked about earlier to that number. So in the second example here, we have a Russian word for author, and the output, assuming a numeric value of 3, is Russian for 3 authors, where the number 3 is formatted as a word instead of a digit. In Siri, we often deal with lists of data, such as collections of recipients to send a message to. To support this, CAT has built-in functionality to format lists of items with appropriate comma separation and inclusion of the word for and or in each locale. So for example, Pascal, Abigail, et Pierre in French. You can also combine other features such as the inflection attribute. So in the second example here, we prefix each noun with the appropriate definite article for the gender, and we use the appropriate or word being o in Spanish. So el taco, el burrito, or la fajita. For more complicated cases, you can also add a specific prefix to each element, and you can customize the separator string. One of the particularly powerful features of CAT is what we call semantic concepts. To explain what this is, imagine if you have some enumerated string that might take a few values. For example, Siri lets you say things like call my mum or call my brother. You can imagine that in our code, we have a relationship setting that might have a value like mother or brother. And we may want to produce dialogue that includes that relationship, such as calling your mother. So we need a way to be able to translate the term mother across all of our locales, because at runtime, we're just going to receive a string like mother, which is always going to be in English. It's essentially a key. A semantic concept lets us handle this case by providing the translation for all possible values of that parameter string. So in the example here, we can see that the key mother returns anne in Turkish. We can also provide the correct translation for different inflection constraints. So you can see in this example, for son, we provide the Turkish term for various inflections. Another important aspect of semantic concepts is that they let you provide context-specific translations for a term. So for example, the word cometa in Spanish can mean two different things based upon the context. It can mean kite or it can mean comet. In the former case, the word is feminine, and in the latter case, it's masculine. This can be represented using semantic concepts, where we can define a context of toys with a specific translation of kite in Spanish as cometa, and we can specify that the gender of that word is feminine. We can also define a context of astronomical terms, where the translation of comet is cometa again, but in this case, it's masculine. And so we let you define, when you're defining a parameter type, you can also specify if that parameter type should be treated as a specific category of semantic concepts. So the relevant translations will be used to produce the right translation with the right gender in the right context. The last feature we'll talk about today is support for locale-aware text transformations. A simple example is producing uppercase and lowercase versions of a piece of text where we handle accents correctly instead of only ASCII characters. We also have a mode where we will automatically capitalize the first character of a segment of text if it ends up appearing at the start of a sentence, i.e. the start of a string or after a sentence-ending piece of punctuation. So this way, translators don't have to write a lot of complicated conditions to figure out if a piece of text is at the start of a sentence, or provide alternative lines of dialogue just to change the casing of a single character. Another mode we support is to surround a piece of text with appropriate quote characters for the locale. And you can see an example of this where this produces the double angle brackets for Spanish dialogue. Okay, so let's put all of this together into a single example. Here we have a single line of dialogue in a CAT file that uses a number of the features we've talked about today. Let's walk through how it produces its output. The first part is just a static piece of text for your last message with. Then we dynamically output the number of items in the contacts array that's passed in at runtime, and we format that number as words. So this produces the output 3 spelled out as a word. Next, we use the quantity element to correctly pluralize the word person. We do this based upon the same number of items in the contacts array. In this case, it's 3, so we use the other text to pluralize the noun, which outputs people instead of person. Next, we output the value of the variable contacts surrounded by parentheses. The contacts parameter is an array, and we specify that we want to use our AND list formatting. So this outputs the name of the 3 contacts, separating them with commas, and using the English word and before the last one because we're dealing with English text here. Finally, we output the actual message that's contained in a parameter called message. We embed this inside of a transform tag where the mode is quote, so we add locale appropriate quote characters around the message. So that's all I wanted to cover today, but I'll leave you with a few final thoughts. As I mentioned earlier, you can put SSML markup inside of a CAT file to control TTS prosody. It's also worth noting that CAT files are being used today within Siri. They support all 23 languages and 40 plus locales that Siri supports. They run on all Apple hardware and all operating systems like macOS, iOS, tvOS, and watchOS. And the underlying library that performs all of the localized inflections also runs on Linux. And finally, we've really only skimmed the surface of what CAT can do here today. There's a lot of additional functionality that our engineers, writers, and translators can use to ensure that we produce rich, grammatically correct dialogue. And while some of this functionality is also available in other frameworks like ICU and CLDR, CAT also provides a lot of capabilities that are not available in other message formatting frameworks. So that's all I wanted to cover today. And so on behalf of George and myself, thank you very much for listening.